Everyone is talking about artificial intelligence, and it's no wonder. Its abilities can seem so human that it creates both incredible excitement and a lot of confusion about what this technology actually is.
This gap between what we imagine AI to be and what it really is creates a fundamental misunderstanding. And this isn't just a small detail, it's absolutely central to understanding both the power and the real world risks of this technology.
When most of us picture AI, our minds often go to what we've seen in movies and books. We imagine a single, flexible intelligence that can learn, reason, and solve basically any problem a person can. This idea has a name: artificial general intelligence, or AGI.
So, on one hand, you have this powerful idea of a general AI, an adaptable, all purpose thinker. But the reality of the AI we have today is something very different. It's called narrow AI. These systems are incredibly powerful, but they're specialists, built to do one specific thing within a very limited context. So, the AI you interact with every single day isn't one big emerging mind. Instead, think of it as a huge collection of separate, highly specialized tools, where each tool is designed for just one job. The technical term for the technology that exists today is narrow AI. Its entire identity is defined by its focus. It can perform one task or a very small set of tasks incredibly well, but it simply cannot step outside the boundaries of its programming. And these specialized systems are already all around us. The algorithm that recommends what you should watch next, that's narrow AI. The system that powers your web search or the virtual assistant on your phone, also narrow AI. They are extremely useful, but each one is locked inside its own domain.
So if these systems aren't really thinking like a human, then what are they doing? Well, the most advanced systems we have today, especially large language models or LLMs, work on a principle that is surprisingly simple in concept, but absolutely massive in scale. And this is the core idea you need to grasp. An LLM doesn't understand language, it predicts it. After analyzing enormous amounts of text, it learns the statistical probability of which word is most likely to come after another. It's basically an extremely sophisticated form of pattern matching. Here's a simple look at how that works. When you give it a prompt, the system breaks your words down into pieces, called tokens. Then, it analyzes those tokens to calculate the most probable next token in the sequence. It adds that new token and then does the whole thing over again, building a response one piece at a time. It's a purely mathematical process, not a cognitive one. This process of just predicting the next word is remarkably good at mimicking human communication, but the fact that it's purely statistical points to a huge divide between this machine process and actual human thought. The answer to what's missing is something so fundamental to us that we hardly ever notice it. It's called the common sense knowledge problem, and right now it's the biggest barrier for artificial intelligence. Common sense is that massive, unspoken library of assumptions we all have about how the world works. It's not the kind of knowledge you learn from reading a book. It's what you learn just by living in the physical and social world. For instance, we all have an intuitive grasp of basic physics. You know that if you push a pen off your desk, it's going to fall. You don't need to calculate gravity or air resistance. You just know. For us, this is completely effortless. But an AI trained only on text from the internet doesn't have a body. It has no physical experience. It can describe gravity because it's read the word a million times, but it has no intuitive sense of what it means for that pen to fall. Without that foundation, it can't truly understand the world it's talking about. This lack of common sense has very real consequences. It's the reason why an AI can sometimes give you an answer that isn't just a little bit wrong, but is completely, bizarrely, and almost hilariously wrong. This leads to a strange phenomenon, where an AI system can seem absolutely brilliant one second and then utterly nonsensical the next. Its intelligence is fragile because it isn't built on a real understanding of the world. Instead of learning the actual concept you're trying to teach it, an AI will often find a clever workaround. It's called shortcut learning. The system finds the easiest possible correlation in the data to get the right answer, even if that correlation has nothing to do with the actual problem. A famous example of this involved an AI that was trained to identify cows. The problem was, most of the training photos showed cows standing in grassy fields, so the AI didn't learn to recognize a cow. It learned a much simpler shortcut. If there's a lot of green grass in the picture, call it a cow. This works perfectly until you show it a picture of a cow on a beach.
And this gets to the heart of the matter. The most immediate risk from AI isn't some malicious superintelligence. It's what you could call confident incompetence. A system that produces an answer with absolute certainty, but lacks the common sense to know that its answer is wrong. All of this points to a much more accurate way to think about AI. It's not a less developed version of human intelligence, like a child that will one day grow up. It's an entirely different kind of intelligence. If we compare them side by side, the distinction becomes clear. Human intelligence is general, flexible, and grounded in common sense. Narrow AI is laser-focused on a specific task and learns by finding statistical patterns in data. Our weakness might be cognitive bias, but our strength is adaptability. AI's weakness is its lack of real-world context, but its strength is finding those patterns at a speed and scale that is unimaginable for a human brain. So the real challenge ahead of us isn't just about building bigger and more powerful AI systems. It's about deeply understanding the nature and the fundamental limitations of this very alien form of intelligence, so we can learn to use it wisely. This reframes our entire relationship with this technology, and it leaves us with perhaps one of the most important questions of our time. How do we best use a tool that has almost unlimited computational power, but absolutely no real-world wisdom?